Imagine you're chilling on a field with an apple sitting right next to you. Oh, and you're purple, don't ask me why. But because you brought a red apple with you instead of a red yellowish one, which tastes far better, you're thinking to yourself, you know what, let's throw this away. If you want to calculate basically anything with this flying apple, then you're dealing with projectile motion. So let's say you're throwing this apple at an angle of 30 degrees above the horizontal with an initial speed of 20 meters per second. And it travels 30 times the square root of 3 meters horizontally. Now let's say you want to jump down to get the apple back, since your mom told you to not play with your food. Which is why you want to calculate the height of the hill, so delta y. Now in order to get delta y, we can use some of these equations below. If you watched my last video, then you might be already familiar with a few of them. So the first thing we should do is to use the two trig functions below. With them we can calculate the initial vertical and horizontal velocity. If we now plug in the 30 degrees and the 20 meters per second, we get our two solutions. If you want to know how to evaluate trig functions with angles like sine of 30, then feel free to watch my video about trig functions. Alright, now since we have delta x and the initial horizontal velocity, we can use the delta x equation to solve for t. If we now plug in both values, then we obtain a time of 3 seconds. Now with that in mind, we can finally use the delta y equation to solve for delta y. Also keep in mind that we are on Earth, so due to that the vertical acceleration would be minus 10. If we now evaluate everything, we get minus 15 meters. So now we know that the hill is approximately 15 meters tall. But why is it minus 15 and not 15? Well, it's just because the final position lies under the initial position. Okay, let's say you got the apple back. However, you suddenly remember that your dino nuggets are still in the oven. With that in mind, you become very angry and use all your power to throw the apple. Which is why the apple travels with an initial speed of 30 meters per second this time. However, the angle is 0 degrees this time. Now you want to know how far you have to run to get the apple back. Now let's use the trig equations again. If we now plug in the 0 degrees and our initial speed, we get our two solutions again. Now since our throwing angle is 0, the initial vertical velocity also has to be 0. Okay, let's use it in our equation. How about the delta y equation, with which we can solve for time? Note that we are still on Earth, so the vertical acceleration is minus 10 meters per second squared again. If we plug everything in, then we get our time of the square root of 3 seconds. Due to us knowing the time now, we can use the final equation, which would be the delta x equation. Okay, let's plug everything in and we get our result of about 52 meters.